Weather app patterns part two visualization. So you did the first part in lab 9 of this module, but in this case, what we're going to be looking at is the part two. So in this part, I did tell you for lab that if you don't understand the instructions or at least the functions and how you go about using them, please make sure that you ask because the next part, which would be part two, goes over the scenario base and you'll have to figure out which one you go with which. And that's just to help you more so with critical understanding as well as taking what you've learned and modify it. So if you want, you can download the Streamlit function PDFs that I created. This is one of them, which goes through each of the functions of it and shows you examples with it, along with the syntax of the built-in functions with Streamlit and the concept of it, what gets returned and what doesn't. And so hopefully this was able to help you when you were doing part one. I also have here another part for the weather app, actually, for the functionalities that we'd be using. So for example, how to use title and all the other built-in functions specifically for the weather app so that you're able to understand how to use it. Now for this part here, the first structure that we're going to do, you'll notice it doesn't say to do any importation. It says keep the beginning exactly as before, the imports and everything. So that means you need to remember and go back to your old code. And at the very top here, we're just going to put, don't want that, just going to put import Streamlit as ST, which is what we had before, and import pandas as PD, which is also what we had before. So now that we have that, the next thing it says is keep the beginning exactly as before. We have the import. Now we want to make sure that the uploader still accepts only the CSV files and stores the uploaded file. So in that case, that means we're just going to be reusing that weather data file that we had prior that shows the station and the temperature, the region, and the date. So that's the file that we're going to be reading in here. But we want to make sure that we still have our title so that we can see it. Again, this is a part of the first part. So we're just going to do st.title. And we're going to put inside of here, it's a title that'll look good. So we'll just use this here. And then we'll also say weather patterns analysis part two. All right. So now that we have the header, the next part is we need to use the file uploader to be able to upload the CSV file in here just to make sure that it works. And how we go about using the file uploader is we first are going to start with uh, go uploader. We're first going to start with a variable that's going to hold whatever we want to return. And that's because whenever you do the st file underscore uploader, like I mentioned in class, for lab 9 when we go over that, what it does is it actually is going to return, it's going to return a value to us at the present. So we need to be able to pass in some values, like we have our label that we're going to have for it. We're going to be passing in the typed file that we're going to be reading in, which is a CSV file. And we don't necessarily need to have a key. By default, it will be none, but we do know it's going to return some value. So the first thing we're going to do is put the label. We're just going to say, upload your weather underscore data.csv file. And if you don't remember where this file is, it is located in lab 9, and you should have already had it on your computer for lab 9. The next thing we're going to do, and I always like to have this on a new line, especially when doing videos so that you can actually see it here, but you can keep it all on the same line as long as you separate it with this comma here. What we're going to do is we're going to put the type of file that we're going to need to upload and read. And inside of the type, it's just going to be CSV for this weather CSV file. All right. Then the next thing we are going to do is the next part of this says we want to clean up and read our data. So once the file is uploaded, we're going to access it using the pandas library like we did for lab 9, and we're going to load it into a variable. But again, we need to have a variable on the left side to hold that information so that we can pass it into our read CSV file. So I'm going to call this uploaded underscore file here, and I'm going to assign the return value there. Now that we have this line here, the next thing we're going to do is just use our if statement, similar to what we did in lab. So inside of this, we're going to create a df object, which is going to hold when it reads the file. And then inside of that df, we're going to assign date to the column. So first things first, we need to have an if statement. If the uploaded file is not none, meaning there's nothing inside of it, then inside of here, we are going to do pd dot read underscore CSV. We're going to use our pandas library to access their built-in function to read the CSV file. And we're going to do our variable uploaded file right here. That is going to pass in that uploaded file in there. And because this does return a file or it does return data, again here, we're often going to use the name df here. So I'm going to just do df here. And so that's going to get returned into that df file here. Now, the next thing it says to do is inside of the df object, we need to locate the column date, which we see here at the very top. And when we look at the column date, we have to use it for the date and time function to turn text date into real date objects. So how we go about doing that here is if you remember going through and hopefully understanding what df is, we're going to use that because it read in the CSV file and it's stored in that data into df. Now we're going to actually access it by having our date here. We want to say in the df for date. Now we want to access certain values. So we're going to use pandas and we're going to use our built-in function toDateTime. And inside of their built-in toDateTime function here, the first thing we're going to do is we're going to say, hey, we want to actually access the df date here. So that's going to be the first thing here, df date. And it needs to be capital D and it's date, not data. And then I'm going to also assign to this error here. This is going to be errors equal. And we're going to assign to this anything with the course here. And if you're struggling to remember what all of that is, you can click on this and see an example right here inside of the file that I gave. But inside of here, again, this first part is referring to the date column and the data frame that we have here, hence the df. It's going to convert that text to other forms into a date time object here that Python can actually recognize. And then this errors part here, that's the important part. It just tells pandas that if the value can be converted into date and time, do it. Otherwise, if the value can't be converted, we're going to say bad data, or you're going to see NaN is replaced, or NAT sometimes not at this time will be replaced there. So that errors course is just avoids the crashing of your program. Without this, even if one bad value exists in your column, like a typo or a missing date, your whole script, the whole entire file will fail here. And so this is a way for us to clean up the data and for us to actually just have, once there's a bad value, it's just going to become NAT. So we can easily remove it. And then we would use the drop now later on in the next part. So you can always refer back to that as well. Now, the next line of code that we're going to write is actually going to be the fact that if we want to modify the data. So we're going to be using the dropNuff function in pandas, which drops all the rows that contain at least one of the NaN ANs, which is the missing values, which I just mentioned earlier. So here we're going to use our data frame df equals df dot dropna, hence like dropping the NA there, and then that cleans up that data there. So it's just going to assign the clean data to our df object here, overriding the old one that we've seen. So now that we've finished with actually uploading the file and we've converted the dates and removed hence the incomplete rows by using the method designed to drop the missing data. And for the most part, people did fairly well with this. They understood this process because they remembered from the last lab that we did. The next part of this is we want to create the regional stats here. So what we're going to do is still inside of the if statement here. There we go. Now what we're going to do is we're going to use our df.groupby so that we can get the data by region. And we're also going to be looking at the temperature and the precipitation and summing those up because that's what here is asking us. We want the average temperature for that region, the total precipitation for that region, and we're going to be using the pandas objects to group the data by the region column. So hopefully if you spent time in the lab, because it was pretty short and giving you like word for word code, and giving you the instructions and also the PDF, that you took the time to understand the built-in functions here as well and ask any questions that you needed in class. So here we're going to have our region stats variable that's going to be returning this value. We're going to be using that df group by function. And we're going to group it by the region. And then we're also going to use the AGG, which is aggregate here. And then inside of this, we're going to use the open close curly braces. Now, the first thing we're going to want to get is the temperature. And we're going to want to get the mean there. We're going to separate that by a comma. And then the next one is actually going to be the precipitation. You want to make sure you spell it the same that is inside of the actual file. Otherwise, it will not read the right information. So let's see. PRE, CIP, IT, AT, ION. Okay. And then we're also going to get the sum. Now that we've got the sum there and all of that information, we are also going to make sure that we have our reset of our index here. So we're going to go, oops, okay, typing nothing. So we're going to do dot reset underscore index here, open close parentheses. So what this section is saying is, hey, we want to group by the region, group the entire data set by the unique value region here. This lets us actually apply calculations separately for each region. And then we're also going to use AGG, which is aggregate. Again, you're telling Python that what summary statistics to compute for each group here. And we're using aggregate. And then what we're going to do later on here, specifically, we're saying we want the temperature for each region. We want to calculate the average mean temperature for each precipitation, or for each region, we want the total up of all the precipitations, hence the sum. And then at the very end here, where we use the dot reset index, we're just saying after grouping, the region column becomes the index by default. So the regions column will be our index by default. And this just resets it so region becomes a regular column again, and it's going to be helpful for displaying it as a full table in Streamlit. And we'll be able to see that here shortly. So inside of the instructions where it says we use pandas to group the data by region like we did here. We were able to, within each group, calculate two summaries, the mean and the sum. Now we're going to store this table or the summary table in a new variable, which we did here, region stats. Then we reset its index, which is right here. so that the region becomes a regular column again and it displays this result table on the web app using Streamlit. So we finished this section just by doing that. All right, so the next part of this is us actually displaying it out to Streamlit because we're still not finished yet. We want to display the resulting table to our web app. This doesn't do that. It just does the first part of this, 1 and 2 here. So we're just going to go ahead and display it in Streamlit. So we're going to do ST subheader, and hopefully you become more familiar with this after using it quite a bit. And here I'm just going to do like a world globe here. And we're just going to have a region stats. Then on the new line here, we're going to do ST data frame, and we're using that data frame library there. And this is just going to be able to showcase the values. We're going to do region underscore stats there. I'm going to save that. All right. So now we have displayed out the data. The next thing that we're going to do is we're going to compute the daily average here. And that's not going to take very long because these are some of the things that we've kind of gone through already. So for this one, we're just going to have our daily average here. Again, I always recommend doing the comments, but here we're going to do df.group by, and we're wanting them to group by the date. And then we also want to have our, temperature. And then we're wanting to get the mean, right? That's what we said we wanted up there. We're getting the mean. So we're going to use that built-in function there with mean. And then we're also going to reset underscore the index, have our new index, reset it. And since this whole thing returns back information, we're going to assign it to a variable called daily average. All right, the next thing we're going to do after we've gotten the daily average and we've gotten the mean for it, the next thing we want to do for each date, find the average temperature, record that day, store this in a smaller table in a new variable that represents daily average. This will later be used for our trend chart, which is what we're going to do here. So that means we can move on to step 4 since we've already done, or step 5 since we've already done step 4. So now we're going to move on to step 5 when we're looking at charts. Now for this, for those of you who may have downloaded Streamlit after the Lab 7 where we did download Streamlit, your version may be 3.14 or above. Halfway through the semester, they have updated their information. So some of these chart processes may not work fully for you. But for the most part, from what I've seen, a lot of people have been able to get it working. I think only maybe 3 people haven't so far, the ones that have told me. So we will work on trying to fix that. Or you can just decide to push back your version of Python to be 3.12 or lower. Okay, so here we're going to do the subheader here. And we're just going to have, we can have an emoji that just has a chart going up here. We're just going to call this temperature trend over time. There we go. Then the next thing we're going to do after our subheader is we're going to use the line chart. And that's just because after we create the subheader, we have to tell the user they're viewing the chart next. So now we're going to build our line chart. And it shows how the temperature should change over time. It shows what is the X value, what is the Y value. And we're going to go ahead and do that. So for here, what we're going to do is say st.line chart. And then inside of here, the first thing we're going to put is the daily average, so it knows what data we want to place in there. Then the second thing we're going to do is have our X label. Our X is going to be the date. And keep on doing data, it's date. Sorry. All right, so we have Y here. The next one is going to be temperature. And for the height, in the previous one, we did set it to 400. You can choose whatever height you'd like. I'm just going to keep it at 400. So now that we have the line chart here in the subheader, the next thing we're going to do after we've created the chart here is we want to get also a bar chart for the total precipitation. So we're going to do the same thing, but using a different built-in function. So we're going to have the ST subheader, and then inside of here, we can put some emoji, just put rain with an umbrella. We'll use this one. And then we'll put total precipitation by region. And then inside of here, we're going to do st.bar underscore chart. And the first thing we're going to do is we're going to use our region stats variable that we had up here that we said we would use later. And then we're going to assign to it. And the first one, X, is going to be region. And Y label is going to be precipitation. All right, then the next thing we have is the height is going to be 400 again. All right. And again, if you want, you can choose, like, I would be more than happy to have this on the same line so it's easier for you guys to see through the video. So far, I've only gotten a few feedback on it, and it's fine either wise. But we're just going to make sure we have a comma for each section here. So now that we have our line chart, we have our bar chart. The next thing we're going to look at, and let's check to make sure we got everything. We have the height, the bar chart, we have the region, the line chart, the date and time. So now we need to actually use our short subtitle before each chart to help users understand what they're looking for. We also have that. So the next part of this is we want to just have a general insight summary section. We're going to add a subtitle that says summary insight. Then we're going to use logical reasoning and our pandas tool to define the key insights here. We're going to do this step by step. All right, so the next part of this here is just to have our subheader. We're going to do st.subheader here. And inside of here, we're just going to have, we'll put a light bulb to show that. And then we'll have our summary insights. All right, so the first thing we're going to look at is the wettest region. So since we're looking at the wettest region, I'm going to just have my variable be wettest region. And the next thing it says to do, identify which region has the highest precipitation total by locating the row with the maximum precipitation value. Now, we have used this before. So when it says here, we want to identify the region with the highest precipitation by locating the row with the maximum value. The first thing we need to do is be able to locate the maximum index value. So what we're going to do is we're going to have our region underscore stats variable that we created. We're going to use that lock function, and that lock function there that we've kind of talked about, it just stands for it means label-based indexing. It just allows us to access the row or column using either the label or the index name. And in this case, what we're going to actually be using is our region stats with precipitation, since that's what we're looking at as precipitation. So we're going to still use our region stat variable there, and then we're going to access that specific index. So we're going to say precipitation. And now that we have that there, move this over a bit. So we're locating it by precipitation. The next thing we want to do, still inside of that first, still inside of the second closing brackets here, what we're going to do is we're going to use that EDX max, which is going to locate the maximum value within that data of that precipitation section there. So essentially, It's just going to return the maximum, the index of the maximum value. All right, so now that we have this line and it finds which region has the highest total precipitation and stores its name into our variable lettuce region, we're able to get the highest precipitation index of the row, and we're able to get the name of the region at that specific index, and that gets returned to our variable. Now we need to go ahead and do the warmest station as well. So with the warmest station, we have to group it by the station and find each station's average temperature and then determine the highest mean value. So we're going to have a variable called warmest station, and we're going to use df dot group by, and we're going to group by that station. And then we're also going to access our temperature, and we're going to get our mean using the mean function, and then that's also going to get the maximum index, and we want to use the IDX max function there. So now we have the warmest station. The next part of this that we're going to look at is the trends over time. So we're going to compare the first and last temperature value from our daily average table. If the final value is higher, describe the trend as temperature rises, otherwise call it temperature stable. So we're going to have an if statement here. So let's go ahead and create this value first. We're going to say if last temp, or no, first we actually need to create that. So this is also leading you into critical thinking of, well, if you need to get the last temp and then the first temp, what all can you use to be able to get that? Now we know that we can use lists, right? We know that we can use lists to get the first temp by getting index 0. We can also use a list to get the last index by using -1. So when we go about doing that, what does that look like? What would we be using? And in this case, we know we're going to have a variable called first temp. And we're going to use our daily average variable that we had at the very top. And from that daily average variable, we're going to access temperature because that's what we want to check. Then on the other side here, we're going to use our iLock here. And with this iLock, what that pretty much stands for, since we've used it before and I explained it in the little lab section, it's integer location. So it's used to get a row or value by index number. So it's using the position in the list, not the label. And when we use 0, it's giving us the first value of that index there. Oops. Not there, right? So now that we have the first value, what do you think the last value would look like? We're going to have our last temp variable. Then we're going to say daily underscore average here. Then what we're going to do is access temperature. And then we're going to get our integer location and use -1 to get the last value. So now that we have the first and last temperature in that list there, now we're going to go ahead and we're going to compare it. So we're going to use if last underscore temp is greater than first underscore temp, then we're going to create a variable here called trend, and we're going to assign trend to temperature rises. Then we're going to have our else statement. Now for this one, what do they say trend should be? Trend should be temperature stable. So we're going to go ahead and say temperature stable. So either or, trend will either be temperature rises or temperature stable. And so now that we have that, the next thing that we're going to actually use is we're now going to move on to the next. We're going to be using trend eventually. And before we do, I'm just going to go ahead and initialize trend as an empty string up here so that we can reuse them later on. All right, so the next part of this is we're going to be looking at the correlation. So we're going to use the correlation function to measure the relationship between the temperature as well as the precipitation value. So how we go about doing that, I'm going to have a variable called core. We're going to use our data frame object to access temperature. And then we're going to use the correlation function here. And we're going to use and I'm going to just, because you're not meant to use that. So we're going to I re-changed the variable to just be correlation, just so it doesn't interact with this function, which it won't, but you would rather name your variables different to what is already available to you or any built-in functions. So in this case, I'm going to use a data frame to get the precipitation. And then what we're going to do afterwards, now that we have all of these values, we have our wettest region, we have our warmest region, trend over time, correlation. Now we want to display all of these insights as a neat kind of bulleted summary underneath our subtitle using our Streamlits tech down and formulating our markdown stuff. So we're going to go ahead and do that. So now in this line here, we're going to use our st.write function to write this into Streamlit. And we're going to use our f string here. And I'm just going to use that dash, which is for the bullet. And we're going to say wettest region, colon. And we're going to have asterisk, 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 asterisk. And in between those two asterisks, we're going to have our open, close, curly braces for our placeholder. And we're going to put our wettest region there. Now, the next line here, we're going to do st_write. And we're going to do the same thing, but for the warmest region. And remember, these gives wettest region bold. And you don't want to have a space in between that, just as long as it's right next to each other. So now we're going to have our warmest station, and we're going to do that by average. So we want to showcase to the user average. Then we're going to have our asterisk, asterisk, and then another asterisk, asterisk. And inside of that, we're going to have our placeholder, open, close, curly braces. So now inside of this, what we're going to do is have our warmest station variable placed in there. Now, the next thing we want to do is write our trend. So we're going to do st_write, have our f string here. We're going to say trend, colon. We're going to have asterisk, 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 asterisk. Inside of here, we're going to have our open, close, curly braces, and we're going to put trend. And then lastly, we're going to do that st_write in terms of our writing portion. Here, we're going to have our temperature and our precipitation correlation here. And then inside of here, we're going to have our asterisk, asterisk, open, close, curly braces, asterisk, asterisk. And inside of the open, close, curly braces, we're going to use our correlation variable. And we're going to want to make that 2 floating points. So we use colon.2f. Hopefully you guys remember that. And then afterwards, the next part of this, I'm going to save that, is we're going to look at handling the no file uploaded case. So if you remember earlier, we did our if statement, if uploaded file is not none. So if it is inside of our uploaded file variable and it works, then we can execute all of this. But we need to also have an else statement. So we finished with the summary. So we're going to back out of the if and go right underneath it for the else. And now we're going to be looking at how to catch or handle this information. So here we're just going to do st_info. And we're just going to say, please upload the file named, and we're going to do a bold. And it's going to be weather underscore data dot CSV to begin, because you can't do any of the other stuff without the right data. So now that we have this here, now we want to run it so we can actually see what it looks like. So I'm going to show you that. All right, so at the very bottom here, since it's inside of my CS120 portfolio, I'm just going to do Streamlit run, and we're going to do the weather app part 2.py, because that's what I named my file here. Press enter, and then it shows up over here. Let's move it. Okay, so we see this information here. We want to make sure we get the path to the file. So I'm going to just copy that path, copy the path. Gonna do a file uploader. And we're gonna move this here. And we're gonna click on the weather data.csv file. And we see here we get the region stats, which works great. Again, I keep putting data there and it's supposed to be date. So I need to go back and fix that. Which line is that? 25. So we're gonna go ahead and do that. Yep. Gonna save it now and rerun again. So now everything should work perfectly fine. We have our region stat, our temperature trend over time here. We have our total precipitation based off of the region. We have our summary insights here with the wettest, with our bullets and capitalized letters. Everything is here perfectly fine. So now all you have to do is submit this file here, and you're good to go for this weather app too. If you have any questions about any of this functionality, feel free to let me know and I'll be happy to help you out with it.